In mathematics, we use a symbol factorial. Explaining about factorial. This is a notation which is used in mathematics. See what means a factorial. Suppose I put here product of first 10 natural numbers. This is product of 10 natural numbers. In short, this is denoted as 10 factorial. If I give here product of 50 natural numbers, then this is written as 50 factorial. Now see this statement I am explaining as 50 factorial is 50 into, taking in reverse order, 50 into 49 into 48 into, taking in reverse order, product is up to 1. So 50 factorial is product of first 50 natural numbers. 50 factorial is product of first 50 natural numbers. Statement I have written in different way. Now look here. If you observe this part of product, then it is a product of first 49 natural numbers. So this can be expressed as 50 into, this is now 49 factorial. So 50 factorial is 50 into 49 factorial. If we take here 100 factorial, 100 factorial can be expressed as 100 into 99 factorial. So it is product of first 100 natural numbers. Similarly, now n factorial. N factorial is product of first n natural numbers. That is n factorial is 1 into 2 into 3 into up to n. This is product of first n natural numbers. Here the second last number will be, in this series, the second number will be n minus 1. If this is 100, before 100, 99 comes. If this is 50, this will be 49. So now this product, it can be expressed as n into, now this is what? N minus 1 factorial. So like 100 factorial is 100 into 99 factorial. 100 factorial is 100 into 99 factorial. If we want to express same statement for n plus 1 factorial. So n plus 1 factorial is n plus 1 into, go one step back, into n factorial. If we want to express statement for n minus 2 factorial, so n minus 2 factorial is n minus 2 into, one step back. So one step back, that is decrease 1 from this number, so n minus 3 factorial. So this is about factorial. Now, say if 3 factorial, value of 3 factorial is 3 into 2 into 1, so it is 6. 3 factorial is 6. Now I calculate 4 factorial. 4 factorial is 4 into 3 into 2 into 1. 4 factorial is 24. Now I calculate 7 factorial. 7 factorial is 7 into 6 into 5 into 4 into 8 into 2 into 1. Product of first 7 natural numbers. So this is equal to 1 into 2, 2 into 3, 6 into 4, 24 into 5, 24 into 5, 120 into 6, 720, 720 into 7, that is 5040. 7 factorial is 5040, 720 into 7. Now look here, say 3 factorial plus 4 factorial is 6 plus 24, this is 30. 3 factorial plus 4 factorial is 30 and 7 factorial is 5040. So it is clear that 3 factorial plus 4 factorial is not equal to 7 factorial. We can't take addition like this, that 3 factorial plus 4 factorial is 7 factorial, or 10 factorial plus 5 factorial is 15 factorial. That is not true. So we are not allowed to take addition like this. 3 factorial plus 4 factorial is not equal to 7 factorial. Suppose if question is 1 upon 5 factorial, 1 upon 6 factorial plus 1 upon 7 factorial equal to x upon 8 factorial, then find the value of x. 1 upon 6 factorial plus 1 upon 7 factorial equal to x upon 8 factorial, then find the value of x. So say here this is x upon 8 factorial. It is equal to 1 upon 6 factorial plus 1 upon 7 factorial. Starting from this equation, this implies x upon 8 factorial, 1 upon 6 factorial, 1 upon 7 factorial. Now look these numbers. See, minimum is 6 factorial. Minimum is 6 factorial. Minimum keep as it is. And the numbers which are greater than minimum convert into minimum. That means 7 factorial we convert into 6 factorial. So 7 factorial we can express as 7 into 6 factorial. And 8 factorial can be expressed as 8 into 7 into 6 factorial. Say here 100 factorial can be expressed as 100 into. Now 99 factorial is 99 into 98 factorial. We can continue such procedure. You can leave this product, you can end the product at any number by leaving factorial symbol. So here 8 factorial is 8 into 7 into 6, then leave factorial symbol. So that is x upon, this is 56 into 6 factorial equal to, now here 1 upon 6 factorial common. 1 upon 6 factorial common, put here 1 plus 1 by 7. This is common. So that is x equal to, so this will be cancelled. 56 into, taking here LCM, 7 plus 1 upon 7. 7 into 8, 56. So x is 64. So when using the factorial can be used at any step when showing the given number as product. Sometimes, suppose we want, as for example, we want value of 15 factorial upon 18 factorial. 15 factorial to 18 factorial. So say here, it is 15 and 18. 15 is smaller. Smaller number keep as is. Greater number convert into smaller. So 18 factorial can be expressed as 18 into 17 into 16 into 15 into 40 up to 1. So 18 factorial is product of first 18 natural numbers. 1 to 18. But after this number, here this is, which part is left? 15, 14, 13 up to 1. So this is product of first 15 numbers. So, and the product using symbol 15 factorial. So 18 factorial is 18 into 17 into 16 into 15 factorial. Because here 15 factorial is given. So this will be cancelled. And this can be calculated. This value can be calculated using calculator. Suppose 3 factorial into 7 factorial upon 10 factorial. Now we want to find value of this expression. So look, this is 7 factorial. 7 factorial. 3 factorial is 3 into 2 into 1. This is 3 into 2 into 1. 7 factorial keep as is. 10 factorial can be converted into 7 factorial. So 10 factorial can be expressed as 10 into 9 into 8 into 7 factorial. If suppose here in this question 6 factorial given, suppose here if 6 factorial is given, then take one more step. 10 into 9 into 8 into 7 into 6 onwards, that is leave by 6 factorial. So this can be cancelled. And here this value can be calculated. 3 into 3 9, 2 into 5 10. So 5 into 3 15 into 8 into 7. This can be calculated using calculator. If you have 7 different photos and you want to arrange any 4 photos in a linear way on a wall, in how many ways it can be done? You have 7 different photos. Say 7 photos. Suppose that photo A, photo B, photo C, D, E, F, G. Suppose that these are 7 different pictures, 7 photos, and you want to arrange any 4, only 4 photos in a line, in a linear way, on a wall. So everyone in family may have different choice. A member can choose this 4 photo, some other member can choose this 4 photos. And after choosing 4 photos, everyone will have different choice to arrange them in a line. Suppose if someone choose out of these 4 photos, if a member choose A, B, F, G. Suppose someone choosing these 4 photos. Now suppose you want to arrange here A, then here D. Suppose you want to arrange A, second place B, third place F, fourth place G. You want to arrange them on a wall by this way. This is your choice. But it may be possible that some another family member suggests that at the last F looks better. So some another member wants to arrange in this way. That member likes F at last, A at first, B at the second place. So this is second arrangement. So selecting any 4, these 4 pictures or 4 objects can be arranged by many ways. These all are different arrangements. So such different arrangements are permutations. If someone change at least one picture, suppose instead of D, I take B, and if D is replaced by B, wherever D is taken, if D is replaced by B, then again this is a new permutation. So distinct permutations, that means select any 4. After selecting, they can be arranged by many ways, and take pics of all these arrangements. Arrangement of 4 pictures on a wall. Set 4 pictures on a wall. Every time take a click. No any photo should be repeated in taken clicks by camera. That means different arrangement, different permutation. So how many such distinct permutations can be done? That is the question. So here what we perform procedure, say first place. First place can be filled up by choose any one from these 7. So first place can be filled by 7 ways. Suppose in first place I have selected D. D is taken. It is fixed. Now how many are left? 6 are left. So second place can be filled up by 6 ways. Suppose in second place this is taken. Now 5 photos are left. So third place can be filled up by 5 ways. Suppose this is taken. Now 4 are left. So this can be filled up by 4 ways. So total here 7 photos are given and 4 are arranged. So total number of permutations. Permutation means linear arrangement. This means linear arrangement. Total number of permutations of 7 objects. We have arranged this given 7 objects. But out of 7, how many taken? 4 are taken at a time. So permutations of 7 objects taken 4 at a time. And here no repetition is possible. Any one photo taken, you can't fix the same photo in second place because every photo is unique. So it is without repetition of objects. equal to 7 into 7 minus 1 into 7 minus 2 into 7 minus 3. Here I am explaining one formula. So that's why I am writing here in detail. 7 objects, out of 7 objects, 4 objects are taken. They are arranged in a linear way. So this is the total number of linear arrangements. And total number of permutations of 7 objects taken 4 at a time. In short, this is denoted as 7 objects are taken. Out of 7 objects, 4 are taken at a time. This is number of objects. From given objects, how many objects you have arranged, that number we keep here, 4. So this is 7 into 7 minus 1, 6 into 7 minus 2, 5 into 7 minus 3, 4. That means begin from 7 and go back till 4 steps. Begin from 7, that is first step. Go back, second step, third step, fourth step. So take up to 4 steps. If suppose you are given 10 objects. From 10 objects, you want to arrange 6 objects. Out of 10 photos, you are asked to arrange 6 photos in a line. So total number of permutations of 10 objects taken 6 at a time, it is equal to 10 into, now beginning from 10, that is first step. How many steps we have to go back? 6 steps. So 1, 2, 3, 4, 5, 6 steps back. If suppose 100 objects are given, 50 objects are given, and you want to arrange any 3 objects. So first place can be filled up by 50 ways, second place by 49 ways, third place by 48 ways. So here 3 number is given, take 3 steps. 6 number is given, take 6 steps. But go back. And this is the beginning. 10, so put here 10. 50, so put here 50. So in short, this can be expressed as, if n objects are given, then total number of permutations of n objects, this can be written as, here I am putting reason, total number of permutations of n objects, total number of permutations of n objects taken r at a time, without repetition, of objects, without repetition of objects, this number is denoted and defined as, this is denoted as NPR. P capital, put here R. NPR is, now begin from N and go R steps back. See, this was 4, so taken 4 steps back. This is 6. 6 steps back. 3 steps back. See what is happening here. This is 74. Look here. Beginning is 7. Then in next step 1 is decreased. Next step 2 is decreased. Next step 3 is decreased. That means if the number is 4, in last step you have to decrease 1 less. This is 4, 3 subtracted. So this is 6. So here out of 10, 1 less is subtracted. So this is 10 minus, this is 10 minus 5. 50p3. This is 3. So at last 2 is subtracted. This is 48. So it is what? 50 minus 2. This is 50 minus 2. This is what? 10 minus 5. 1 less. 6 given, subtract 5. 3 given, subtract 2. 4 given, subtract 3. That is for last number. So here r is given, so subtract r minus 1. So beginning from n, next step subtract 1, next step subtract 2, and at last from n subtract 1 less, that is subtract r minus 1. So that is NPR is n into n minus 1 into n minus 2 up to n minus r plus 1. This is a result. Now see, I explained this type of question. Once again, from this question, I want to write one more result. Result 2. To explain this result, here taking this question. So here 1, 2, 3, 4, 5, 6, 7. All objects are distinct. 7 distinct objects. 7 digits are given. 7 distinct digits are given. We want 4-digit number if repetition is allowed. With repetition, 4-digit numbers. Now see, this place can be filled by 7 digits are given. See, all are distinct. Nowhere 0. So this can be filled by 7 ways. Now repetition is allowed. So again by 7 ways. Again by 7 ways. Again by 7 ways. That means total number of permutations of n objects. 7 objects. These are 7 objects taken 4 at a time, and repetition is allowed. With repetition, it is equal to 7 into 7 into 7 into 7, that is 7 raised to 4. Now I am putting this statement in general, that total number of permutations of n objects taken r at a time with repetition of objects is it is equal to, say this was n, this was r, so n raised to r, it is n raised to r. If objects are distinct and without repetition they are arranged, then this notation is used. This is used in case of without repetition. But here repetition is allowed. So total number of permutation of n objects taken r at a time, it is n raised to r. Now see one more result. Just I explained that. Suppose we want to calculate 10p4. 10p4 is 10 into 9 into 8 into 7. This is 10p4. Beginning from 10, go 4 steps back. Now this product, this can be expressed as, see what I do, to this value I multiply and divide by, see what I am doing, I am taking this product up to 1, 6 into 5, 4, 3, 2, 1. So this is extra, we can't change value. So whatever value we have multiplied, we divide by same. So here multiplied and divide by 6 factorial. This is 6 factorial. Previously product was from 10 to 7. Then after 7 multiplied divided by 6 factorial. So now what is it? This is product of first 10 natural numbers. So it is 10 factorial. And this is 6 factorial. Now look here. This is 10. So we have set here same number 10 factorial. And the denominator is difference of these two numbers, factorial of difference of these two numbers. So here we are getting result that NPR equal to n factorial upon difference of these two numbers, factorial of difference of these two numbers. So difference of these two numbers is n minus r. This number should be always greater. This should be greater than r. It can be maximum r. It should not be less than r. Otherwise, this will be negative. So remember here, n is total number of object. N is total number of object and r is number of objects which are to be arranged. So value of r is always more than or equal to 1, less than or equal to n. The formula is for r greater than or equal to, less than or equal to n, more than or equal to 1. If you are given 10 objects, maximum you can arrange 10 objects. Out of 10 you can't arrange 15. Out of 10 you can arrange 10. Out of 10 you can arrange 9. So this value is always less than or equal to 9. Out of 10 you can arrange 1. So r can be 1 equal to 1. And out of n, if you don't want to arrange anything, then suppose that r is 0. So say, if r is 0, if r is 0, then NC0, NP0, sorry, NP0 is n factorial upon n minus 0 factorial. So this is 1, NP0 is 1. That means if n objects are given, out of given n object, you don't want to arrange anything. So it can be done by one way. And which is that way? Don't do anything. That is the way. So 1. NP0 is 1. So this formula can also be taken for R greater than or equal to 0. R can be taken 0. Therefore, NPR is equal to n factorial upon n minus r factorial. It is true for r more than or equal to 0, less than or equal to n. So remember, NP0 is 1. Now, if we take r equal to n, taking r equal to n, putting here r equal to n, then putting here r n, npn is n factorial upon n minus n factorial. Now npn is n factorial. npn is n factorial. Beginning from n, go n steps back. Beginning from n, going n steps back, you will reach at 1. So npn is product of n natural numbers. So npn is n factorial. It is equal to n factorial upon 0 factorial. So that means 0 factorial is 1. So we are getting here result. 0 factorial is 1. NPN is n factorial. So this was the explanation for this result, and how this is derived, that is the explanation in this example. How many 3-digit even numbers can be made using the digits 1, 2, 3, 4, 6, 7. So here given digits 1, 2, 3, 4, 6, 7. So these are 6 digits. 6 digits are given. We want 3-digit even number. Now to have even number, any number is said to be even if number at unit place is even digit. So first of all, you have to focus on a unit place because required number is even. So to have even number, this place which digits are allowed, here you can put 2. Here we can put 2, or we can put 4, or we can put 6. In these 6 digits, 2, 4, 6 are even. So any one from these 3 can be taken here. So this placed by 3 ways. So beginning should be from this place. This is step 1. Unit place unit place can be filled by 3 ways. Number of ways are 3, but we select in any one from these 3. Suppose that you have selected 4. Suppose 4 is taken here. Now, no repetition allowed. So 4 should not be repeated in 10s place or 100s place. So now, except 4, these places can be filled by, if you take this place, then this can be filled by 1, 2, 3, 4, 5 ways. Then next by 4 ways. Here in first and second place, you can take any digit. Even is defined from a unit place. Here you have to take care that the unit place should be filled by this thing only. Here you can give any digits, and because without repetition, any one digit from this is taken, if 4 is taken, 5 are left, so this by 5 ways and this by 4 ways. So 5 ways, 4 ways. Otherwise, first place by 5 ways, then do second place 4 ways. So remaining 2 places. Remaining 2 places can be filled up by 5 into 4 ways. So total number of required numbers equal to 5 into 4 into 3. There are 60 numbers. Say in this question, this is also question of numbers. How many 6 digits numbers can be formed from the digits? Their given digits are 0, 1, 3, 5, 7 and 9. These are 6 digits. We want a 6-digit number. 1, 2, 3, 4, 5 and 6. Now we want a number divisible by 10 and no digit is repeated. So to have number divisible by 10, any number is said to be divisible by 10 if digit at unit place is 0. So this 0 should be fixed in the unit place. So this is fixed one way. 0 is fixed, and so from remaining 5 digits, remaining places by 5 ways, 4 ways, 3 ways, 2 ways and 1 way. Therefore, total required numbers equal to 5 into 4 into 3 into 2 into 1 into 1. There are such 120 numbers. Now here, from a committee of 8 persons, in how many ways can we choose a chairman and vice chairman? From these 8 persons, we want chairman and vice chairman. Assuming one person cannot hold more than one position, that means repetition is not allowed. So say here, there are two positions. This is for chairman and this position is for vice chairman. Now selection of chairman. Selection of chairman can be done by from 8 persons, any person can be selected. So here this selection by 8 ways. And selection of vice chairman, because same person should not take another post. That's why whoever is selected as chairman left that person. So 7 are left. So out of 7, this can be selected by 7 ways. So here we are doing the selection. Here selection. Selection by 8 ways, 7 ways. So one action by n ways, another action by n ways. Then both actions in order can be performed by 8 m into n, that is 8 into 7 ways. So therefore, total number of selection of officers equal to 8 into 7, that is 56 ways. Find n if n minus 1p3 is 2 and p4 is 1 is to 9. So here n minus 1p3 is 2 and p4 is 1 is to 9. Now n minus 1p3 n minus 1p3, this is ratio, upon np4 is 1 by 9. So here by formula, beginning from n minus 1, taking product 3 step back. So n minus 1, n minus 2, n minus 3. Beginning from n minus 1, go back 3 steps. Upon np4 is beginning from n 4 steps back. So n itself is first step, second step, third step, fourth step. It is equal to 1 by 9. So here this will be cancelled. So 1 by n is 1 by 9. So value of n is 9. Now in this question, we want the value of r. 5pr. Here 5pr is 2 times 6p r minus 1. In question of finding r, we shall use this formula. npr is equal to n factorial upon n minus r factorial. R is unknown. So beginning from 5, how much step we have to go back, that is unknown. In this question it was known, 3 steps, 4 steps. So in case of unknown r, we use this formula. So applying this formula, 5pr, so 5pr is 5 factorial upon 5 minus r factorial, n factorial upon factorial of this difference. It is equal to 2 into, again using this formula, npr. Say this is in case of r. So by this formula, 6 factorial upon difference of these two numbers put in denominator. So difference of these two numbers, 6 minus r minus 1. So 6 minus r plus 1 factorial. So this is implies 5 factorial upon 5 minus r factorial equal to 2 into 6 factorial upon 7 minus r factorial. Now look, this is 5 minus r factorial, this is 7 minus r factorial. This number is 2 units greater, 2 factorial more. As for example, suppose 98 factorial, this side 100 factorial. One side 98 factorial, other side 100 factorial. So in case of such calculation, I am discussing about the denominator. 98 factorial की कैसे is 100 factorial convert into 98 factorial. So 100 factorial can be expressed as 100 into 99 into 98 factorial. So this can be removed. So applying this method here, so this 5 factorial, this is 5 minus r factorial, 2 into, because on left side this is 5 factorial, 6 factorial we express as 6 into 5 factorial. 7 minus r factorial, this is 5 minus r factorial. So thinking by this way, 7 minus r factorial is 7 minus r into 6 minus r into 5 minus r factorial. Like if this is 100, so what I have done, 100 into 99 into 98 factorial. So this 98 factorial can be cancelled. So therefore, now taking this number on this side, 7 minus r into 6 minus r is 12. Now this equation can be solved by two methods. Say showing here both ways. First method is left side, it is product of two consecutive numbers, and this number because can be expressed as product of two consecutive numbers. Whenever both sides numbers can be shown as product of two consecutive numbers, then this method is applicable. These are consecutive numbers, these are consecutive numbers. So in this case, 7 minus r into 6 minus r, now this can be expressed as pattern of left hand side. See, I keep here 7, I keep here 6. 4 is 7 minus 3. This 3 is 6 minus 3. Now compare both sides. In place of r, you can see we are getting 3. This is first method. Or second method is expanding this 7 into 6, 42, minus 7r minus 6r, so minus 13r plus r square equal to 12. Therefore, r square minus 13r plus 13 is 0. That is r minus 3, r minus 10 is 0. So r is 3 or r is 10. But look, in question, this term is 5pr. So this number should not be greater than this number. Remember, in NPR, maximum value of r is n. It cannot exceed n. So because r 10 is more than 5, this is not defined. But But here r equal to 10 is not possible, because for r equal to 10, 5br is not defined. So possible value of r is 3. Therefore, r equal to 3. So remember in this chapter, small r and small n both are always natural numbers. Small r can be 0, but no one can be negative, no one can be fractional. And in NPR, this must be maximum n. It should not be more than n.